Stoichiometry. What the heck is that? Well, we've been talking about chemical reactions and balancing them, and we've been talking about moles. Stoichiometry combines those two concepts. Okay, so in this unit, well, we only have 3 days left together this school year, this crazy school year. So today I'm going to discuss with you what stoichiometry is and go through some problems, and then I'm going to give you a worksheet. So tomorrow you're just going to be able to work on the worksheet. Next Tuesday, because Monday will be Memorial Day, next Tuesday I will do a lab for you, moles of iron and copper, which will put together the last things that we've been doing. And so that's going to be your summative activity. You will have to write up the lab from what I do and manipulate the data and then write your CER conclusion. Something to look forward to, right? Okay, so why did I put these delicious looking chocolate chip cookies on this? Well, let's look at the ingredients list. Let's talk about this. Okay, the ingredients. They're kind of like the reactants in a chemical equation, a chemical reaction. In a chemical reaction, you take a couple of things and you do something to them and you get something totally different with all different properties. When you bake cookies, you take all of these ingredients, you mix them up, you bake them, and you get something totally delicious that's not like any of these by themselves. I don't know about you, but I don't eat butter by itself or raw eggs. Flour's pretty gross. Baking soda is really gross. But if you mix them all together and bake them, you get something totally different. Okay, so you're going to bake some chocolate chip cookies and you realize you have all of the ingredients except you only have 1 egg. What are you going to do? You're just going to not make the cookies? You can't go to the store and buy more eggs. Can't do it. What are you going to do? And if you have chickens in your backyard, no, you can't go out and get another egg. Okay. You're just going to not make cookies? No, you really want these cookies. So, if you only have 1 egg, let's look at our ingredient list. It says we need 2. Well, I have 1. So I have half the number of eggs that I would need to make my cookies. So what if you cut all of the rest of the ingredients in half as well, and then you just mixed up your cookies and baked them? Would that work? Well, yeah, it should. What would the difference be? Well, you'd only get half the number of cookies. Let's look. How many cookies would we get? Okay, down here it says makes 2.5 dozen cookies. Well, if I only have half the ingredients that I use to make my cookies, I should only get half of the number of cookies. 2.5 divided by 2, or half of 2.5, is 15 cookies. I don't know about you, but I could eat 15 cookies if I was really hungry for cookies. 15 would be all right for me. In fact, probably be better than me eating all 30. Okay, so you know what? That's stoichiometry. That's all it is. So let's talk about it with chemical reactions. All right, stoichiometry, the study of the quantitative. You remember what that word means? Quantity, the amount. So it's the quantitative relationships between amounts of reactants used and products formed. And of course, then it's based on the law of conservation of mass. Remember, you can't create or destroy matter, you can only change it around. So if I start with X amount, X grams, I'm going to end up with X grams. They may be in a different form, but it's still going to be there. All right, let's look at this reaction. So I have, it says 2 sodiums that are solid plus 2 water, dihydrogen monoxide, that's liquid, yields 2 sodium hydroxide, that's aqueous, so that means it's dissolved in the water, plus 1 hydrogen gas. All right, so what does this reaction really say? What is that? What do those coefficients mean? Well, they're talking about atoms. So how many atoms of sodium are needed to make 1 molecule of hydrogen gas? Well, 2 atoms of sodium will react with 2 molecules of water to produce 2 formula units, because this is an ionic compound, and 1 molecule of hydrogen. Now remember, if there's no number there, that means 1. Okay, but can you really count 2 atoms of sodium? Heck no. No way. No way. Okay, what about something like moles? Can we take 2 moles of sodium? We sure could. So this reaction also says that 2 moles of sodium will react with 2 moles of water to give 2 moles of sodium hydroxide and 1 mole of hydrogen gas. Now, why can we interchange those terms, atoms and moles? Because 1 mole of molecules, 1 mole of formula units, 1 mole of atoms of any substance is equal to 6.02 times 10 to the 23rd atoms or molecules or formula units. Because every single atom, it doesn't matter which of the 118 you're talking about, are made of the same things, protons, neutrons, and electrons. So that's why this works. Okay, so let's look at another example. Mole to mole ratio. This is what the basis of stoichiometry, mole to mole ratios. Okay, so according to this reaction, remember, if there's no coefficient in front of a substance, that means 1. So in this, I have 1 mole of nitrogen gas plus 3 moles of hydrogen gas will yield 2 moles of ammonia gas. Okay, now, these are all of the mole ratios. You take those coefficients from the balanced equation, and those are your mole ratios. So, according to my reaction, 1 mole of nitrogen is to 2 moles of ammonia. 1 mole of nitrogen will give me 2 moles of ammonia. 3 moles of hydrogen will give me 2 moles of ammonia. I would need 1 mole of nitrogen to 3 moles of hydrogen. Okay. So all you do is you take your balanced equation and you look at those mole ratios. Okay? What if, say, I had 2 moles of nitrogen? How many moles of ammonia would I get if I had enough hydrogen. Okay, so let's look up here at this. So normally if I have 1 mole of nitrogen, I would get 2 moles of ammonia. Well, if I double that, so if I have 2 moles of nitrogen, I should get 4 moles of ammonia. Oh, I don't like that color. Okay, think of the cookie example. If I use half of the hydrogen, so if I only have 1.5 moles of hydrogen, how much ammonia will I get? I would get 1 mole, half of it. Okay? All right, let's go on. So, when you do stoichiometry problems, you always have to start with a balanced equation. That is always step number 1, balanced equation. Here's my balanced equation. It's the same one I was just working with. And then you look at the mole-to-mole ratios. Okay, we did that. I think you guys are okay with that. Now, what if I went from moles to mass? We can do that. We've been converting moles and mass, so we can do this. Let's look. All right. If you start out this reaction with exactly 3 moles of sodium, how many grams of sodium hydroxide will you get? All right, so we're going to just start out the same way we did when we were doing molar conversions. Figure out what you're given and what do you want. Okay, when I look at this this question, it says if I start out with exactly 3 moles of sodium, that's what I'm given. How many, so that's telling me what I want, grams of sodium hydroxide is what I want. Okay, so I'm going to start off with what I'm given. Write that down. 3 moles of sodium. Okay, times. Now, this is where I'm going to be able to go. This is where I'm going to put my mole ratio from the balanced equation. So I'm given moles of sodium. So I need to put that on the bottom. And I want sodium hydroxide. So I need to put moles of sodium hydroxide on the top. And then I look at my balanced equation. 2 is my coefficient in front of the sodium. So I put the 2 with the sodium. And 2 is also the coefficient in front of my sodium hydroxide, so I put that there. Now, moles of sodium have canceled. So the next thing I want grams of sodium hydroxide. Right now, if I stopped right now, I would have moles of sodium hydroxide. So I need to do another conversion factor where I put moles of sodium hydroxide on the bottom and grams of sodium hydroxide on the top. Now, this is molar mass. So that means I need a 1 for my mole with sodium hydroxide. And I put the molar mass, which is 40 for sodium hydroxide, on top. 23 for sodium, 16 for oxygen, 1 for hydrogen, so 23 plus 17 is 40. That's where I got my 40 from the periodic table. Remember that. Okay, so moles of sodium hydroxide have canceled, leaving me grams of sodium hydroxide. That's what I want, so I'm done. So now I multiply what's on the top and I divide by what's on the bottom. In this case, you have 2 over 2, so that's 1. So you can just kind of disregard that because you're going to be multiplying and dividing by 2. So I'm going to take 3 times 1 times 40 divided by 1. So that's 120 grams of sodium hydroxide. And that's my answer. Okay? All right. So how about that? Questions? All right. Let's keep going. All right. Now, most of the time, we are going to do this type of problem here. Mass to mass ratio. So what if you start out with 2.5 grams of sodium? Because we don't have a balance that masses out moles. So we generally just say, okay, I've got this many grams of this or that, and then we convert it to moles. So normally I'm going to say, okay, I'm going to start out with 2.5 grams of sodium. How many grams of sodium hydroxide will I get? Okay, so this is what I'm given. Grams, 2.5 grams of sodium. How many grams of sodium hydroxide? This is what I want. Okay. So, I'm going to start off with what I'm given again. So I go 2.5 grams of sodium. Now, I have to get to that mole ratio step. So I need to convert my 2.5 grams of sodium to moles times, okay, I'm going to convert grams to moles here. So grams of sodium goes on the bottom so that cancels. Moles of sodium go on top. So it's molar mass, so always 1 goes with the moles. And I'm just going, all right, 22.99. I was just going to say, just go with 23. All right. So now, next, this is the important step. This is my mole ratio step. This is where I look at my balanced equation and I get my mole ratios. Okay, so remember, I'm using the same one as up above. So it was, I'm going to put moles of sodium on the bottom so that cancels, and I want to go to moles of sodium hydroxide. That's what I want to go to. From the balanced equation, 2 and 2. Okay, I'm still not done because I want to get to grams. So my last step then is now, because if I stopped right here, I would be in moles of sodium hydroxide. So now I need to convert from moles to grams of sodium hydroxide. So I need another conversion factor, and I need to put moles of sodium hydroxide on the bottom so that cancels. Grams of sodium hydroxide on top. This is what I want, so I'm done. Okay, this is molar mass. I got it up above. It's 40, and 1 goes with moles because it's molar mass. So this means, once again, it's 2 over 2, so you can just think of that as 1. 2.5 times 1 times 1 times 40 divided by 22.99 times 1. And the answer, let me do it quick. All right, 2.5 times 40 divided by 99. equals 4.35 grams of sodium hydroxide. Okay. Good so far? Not so bad? All right, remember how for a gas, we have to add this. 1 mole of any gas is equal to 22.4 liters at STP. Once again, it will always be at STP for you. Okay, so let's try it. Let's look at this. So I have another reaction here. I could have stuck with the same one because that produced hydrogen gas, but I'm giving you another one. Let's see. It looks to me like it's not balanced because I have 1 nitrogen on my reactant side and 1 nitrogen on my product side, or 2 on the product side. So I need to put a 2 here in front of the ammonia. And let's see, then that gives me 6 hydrogens. So that means I have to put a 3 there so I can get my 6 hydrogens. That gives me 3 oxygens. So that means I have to put a 3 there so my oxygens are good. And then lastly, I've got to squeak a 3 in right there so my coppers are good. Okay, it's balanced. All right, so let's see what I'm trying to find here. What volume of nitrogen gas will you get if you use 2 moles of ammonia? Okay, so this is what I'm given, and this is what I want. Okay, so I'm going to start off with what I'm given. 2 moles why did that? 2 moles of ammonia, NH3. And I want to go to volume of nitrogen gas. Okay, so that means I need my mole ratio step right here to go from ammonia to nitrogen. So on the bottom of this conversion factor, I'll put my moles of ammonia. And on top, I'll put moles of nitrogen. So that cancels. And then from the balanced equation, there's nothing in front of the nitrogen, so that means it's 1. And in front of ammonia, there is a 2. So I put that there. Now, if I stopped right here, I'd have how many moles of nitrogen I get, but I want volume. So I have to do one more step. I have to convert to volume of nitrogen. Volume is in liters, and moles of nitrogen will go on the bottom, but that cancels. My molar volume is 22.4 liters in 1 mole. Okay, so it looks like I'm going to take 2 times 22.4 divided by 2, so my answer should be 22.4 liters of nitrogen. Okay, looks like, and you realize that's because I was multiplying and dividing by 2. All right, so keep going. One more problem here. All right, volume to volume ratio. What volume of nitrogen gas will be produced from 2.5 liters of ammonia gas when 2.5 liters of ammonia gas are reacted? Okay, so I'm going from volume, this is what I'm given, and this is what I want. So I'm going to start off with what I'm given, 2.5 liters of ammonia. Okay, so I've got to convert from moles to liters, right? Or liters to moles, sorry. So let's do that. I'll put liters of ammonia on the bottom, moles. I need to do that to get to my mole ratio step, right? Moles of ammonia on top. It's molar volume, so it's 1 goes with the moles, 22.4 goes with liters, okay? liters of ammonia have canceled. Now my next step is my mole ratio step from the balanced equation. So I'm going to put, since I have moles of ammonia on the top, I'm going to put moles of ammonia on the bottom so that that cancels. And I want to go to nitrogen, so I'm going to put moles of nitrogen on top. Now, from the balanced equation, 1 goes with nitrogen and 2 goes with ammonia. Okay, now I've got one more step because I've got to go from moles to liters. So one more step. Okay, so I need to put moles of nitrogen on the bottom so that that cancels, and liters of nitrogen on top, because that's what I want. See, if you cross everything off, if you leave your labels on and you cross everything off, when you get to the end, if what you have left is what you want, then you know you've done it right and you know you're multiplying and dividing correctly. Okay, so this is molar volume, 22.4, 1 mole. All right, so now look at what I've got here. So I'm basically multiplying and dividing by 22.4. So don't those cross off? Yeah. So when you are given volume of one substance and you want to go to volume of a different substance in your chemical reaction, all you have to do is multiply by the mole ratio. So my answer then would be 1.25 liters of nitrogen, because 2.5 divided by 2 is 1.25. All right, so here, that's what I just said. When you're given volume of one gas and you're going to volume of a different gas in a chemical reaction, all you have to do is multiply by the mole ratio. Okay, now, one last thing. I'm going to put it out step by step with a totally different problem so that you guys can follow along and kind of go through step by step with me. All right. So, now step 1 is always start with a balanced equation. Always. Because you can't get your mole ratios if you don't have the equation balanced. All right, so I've already done that for you. We're going to take 2 moles of phosphoric acid plus 3 moles of magnesium chloride, and we'll get 1 mole of magnesium phosphate and 6 moles of hydrochloric acid. Okay, now, let's say I'm not going to use 3 moles of magnesium chloride. I'm going to use 5.75 grams of magnesium chloride. How many grams of magnesium phosphate will I get? Okay, step 2. Convert grams of given, so that's the given, to moles. This is what I want. All right, so I'm going to start off with my 5.75 grams of magnesium chloride. I'm going to convert that to moles. So I put grams of magnesium chloride on the bottom, moles of magnesium chloride on top. This is molar mass, so 1 goes with the moles, and the molar mass of magnesium chloride is 70, let me look it up real quick. I was going to say 71, but that's chlorine. 71 Oh, 94. We'll say 94.3. Okay? 71 for the chlorine plus 24.3 for the magnesium. All right. Now, that's just the first step. Okay? That's what we do first. I'm not done. I'm going to jump to step 3. Step 3 is put your mole ratio in. So let me copy this real quick. All right, next step. Mole ratio from the balanced equation. Okay, so I want to get rid of moles of magnesium chloride, so that's going to go on the bottom. I want to go to moles of magnesium phosphate, so that goes on top. Okay, so according to my balanced equation, let's scroll it so you can see up here. 3 and 1. 1 mole of magnesium phosphate comes from 3 moles of magnesium chloride. Okay. Now, jump back to the last step. Convert from moles to grams, all right? Okay, let's put in our last step, which is convert back to grams. Because if I look right now, well, let me put this out here. So I have moles of magnesium phosphate here. I'm going to put that on the bottom. And I'm going to put grams of magnesium phosphate on top. Okay, it's molar mass, so that gets a 1. Let me do this very quickly. So I get 262.9 here. All right. Okay. So now, let's go through it and see if everything crosses out that I want to cross out and end up with what I want. Grams of magnesium chloride cancel. Chloride. Moles of magnesium chloride cancel. Moles of magnesium phosphate cancel, leaving me grams of magnesium phosphate. That's what I want. All right. So I'm going to take 5.75 times 262.9 times 1 times 1. And then I'm going to divide by the quantity, 94.3 times 3. So I use parentheses. And I get 5.34 grams of magnesium phosphate. All right. There you go. Stoichiometry. Okay, so I'm going to give you a worksheet so you can practice this. And that's going to be your assignment for the rest of today and for tomorrow. And then next week, I'm going to do a lab for you. And that's going to be your last assignment of this crazy school year. Okay, so if you have any questions, make sure you email me, Zoom me, anytime, just ask. I'll help you through it. Okay, stoichiometry, one of my favorites.